Yes, good afternoon once again. We are back to Sir Josh Made Man's Simple. And today we'll be concluding on our indices aspects. Today we'll be concluding on indices. And after the conclusion of indices, then our next topic will be exponential indices. Now, in our last class, we tried to talk about the fifth law of indices, where where we make mention where we make mention of, mind you, we are dealing with indices. Here we said x raised by minus a. Now, we did one or two examples on this in our last class. So today I'm going to do one or two examples on it before I move to the sixth and the seventh law. Now, here I said if we are having, let's look at examples. If we are having x raised by minus 3, no, this will be solution. We have, I said this minus return to what? 1 over. This minus return to 1 over, and here we have 1 over x raised to power what? 3. Yes. So there is nothing else again to do here, so we are going to stop here. Now, mind you that this minus here has turned to 1 over, so that is why we are not having any minus here again. Now let's look at this question. Question 2. We have 5a raised to power minus 4. Yes, 5a raised to power what? Minus 4. Now when you look at this one is totally different from this question. Now mind you, I told you that this is a coefficient. Yes, can you see? I box it. Is a coefficient. Why? This one is the one that we obey the law of indices. Why? Because a here is standing as the what? As the base. Now we now say okay, 5 times, now what do we have here? A raised to power what? Minus 4. A raised to power what? Minus 4. So the minus here is going to be 1 over. So we have 1 over. Now the a and the 4 is coming down. So we have a raised to power what? 4. Now 5 times 1 will give me what? 5 over a raised to power what? 4. So this is what we will be having. Now, when you want to reverse, mind you, when you want to reverse this case, if you have 1 over x raised to power 3, now I want to reverse this case now. Yes. Now, when you have this and you are asked to come and solve, maybe to reverse it, that what is the reverse or the response of this. Now when you want to do that, you say okay, that here we have x. Now this is what? Minus 1. Are you with me? Now here we have this 1 over 9 is minus 1 minus 1. Then what is the power here? The power here is what? 3. So times 3. So we have x raised to power minus 3. Can you see the way we reverse it? Now, reversing the equation is making with just return back to the what? To the original question. That is one secret about what? About this law. Now, when you look at this question, now let's do the reverse of this answer now. This answer we have here, let's reverse this answer. Reversing this answer, we have 5 over what? A raised to power 4. Now when I want to reverse that, this will be, the coefficient here is 5. So here will be 5 times, that is the coefficient, times 1 over a raised to power 4. Now mind you, 1 over a raised to power 4 here, 1 over here is minus 1. Then here we have 5 times 1. Here we have 5 times a raised to power minus 1 times the power, which is 4. So we have 5 times a raised to power what? Minus 4, which when you multiply together, you have 5 times 5a raised to power minus 4. So that is one of the secrets we have to understand about what about this law of this negative power law. Now we are going to talk about the sixth law. We are going to talk about what? The sixth law of indices. Now let's look at the sixth law of indices. We call it law 6. Now this law 6 of indices, we have the mathematical equation stated as x raised to power 1 over a. Now the name here, you can name it as what? As fractional power law. Yes, because the power here, the power of x here is in form of a fraction. Now I'm going to explain this and this law 6. I'm supposed to take this law 6 and law 7 together, but I'm going to split them for better understanding. Now let's look at example here. Before the example, let's solve further this law. Now when we are having this kind of law, it's telling us that whenever let me explain something better here. 1 over a. Please take note of something very well. This here, this one here is what? The numerator. Am I communicating? Why this one here is what? The denominator. We have the what? The power. Let's call it the power numerator. And what? The power what? Denominator. Now whenever you have things like this, this law is telling us that it is only the denominator, it is only the power of the denominator that will come and stand as a root, coefficient of a root. What do I mean? We have the power, that is the denominator power here is a, and now we are having a root x, all brackets of what? 1. Now can you see here, this one was my numerator and this a is my denominator. Am I making sense now? So that is what we are trying to explain here, that whenever you have things like this, you should always remember that if your power to any base is in form of fraction, then it is the denominator that will come and stand as a coefficient of a root. Am I communicating now? So here we are going to make some emphasis by buttressing on some examples. Now let's look at examples now. Example number 1. Example number 1, if I am having 4 raised to power 1 over 2. Yes. If I'm having 4 raised to power 1 over 2. At this junction, we are to solve that this, what is my denominator of the power? The denominator of the power is 2. So, some people will write saying 2 root 4, just because this 2 is the what? Is the denominator. Yes, no, I said that the other time, that what you're having at the denominator will stand as the number root the base. Then we have all power of 1. But mathematically, I repeat, it is unfair to write something like this. Why? Because this symbol root is what? Is 1 over 2. So whenever you see roots, it's just as if you are telling us 2 or 1 over 2. So if I want to write this mathematically, I will write root 4 power of 1. Why? Why am I doing this? Why isn't that I didn't put this denominator of 2? Why is it that I didn't put it here? The reason why I didn't put it here is because this root is 2 already. So no need for you to put 2 here. Am I communicating now? Good. Now let's move further by explaining this now. Now this, whenever you see anything in this format, this is just a root of 4. That means I told you is what mathematically telling us that it is 2 already. Now when you see something like this, you have to understand the fact that you have to look for what? You have to look for any 2 numbers, because this root here simply means 2. So you have to look for any 2 numbers that you will multiply together to get the what? The number in the root. So what is my number in the root? My number in the root is 4. And this root is mathematically 2 because there is nothing here. So that means what is the 2 number that I will multiply together to get 4? Let me guess. I think that is what? 2 times 2. Now 2 times 2 will give me 4. Now I've gotten the number. And what is that number? That number is what? Is 2. Now getting this 2, that is 2 all bracket of 1. And what is 2 raised to power 1 is what? Is 2. So this is our answer. Now let's look at another example to justify our law. Now this example 2, if I have 4, I'm making use of this power of 4 again, this base of 4 again rather, 4 raised to power 3 over 2. Oh no, I will do that. Let me use 25 now. Let me use 25. Okay, let's use this now. Yeah, let's use this. 1, 2, 5 raised to power 1 over 3. Yeah, raised to power 1 over 3. Now when you are asked to solve this now, 125 raised to power 1 over 3, the power now, the power is totally different from the power we are having here. Now when you want to solve this, just follow the law. The law is telling us that the denominator of the base, the denominator of the power rather, will come and stand as a base. Now as at this junction now, this denominator of this power is more than 2. So here I'm going to write 3 root 125. Why am I putting 3 here? Because here is more than 2. But here I'm not putting the 2 because here is 2. And root is always what? Is always 2. Now we have power of raised to power 1. The numerator will always come back and stand here as what? 1, because that is what we are having there. So mind you, repeating what I've said here the other time, then we are going to repeat here again. I said that this is 3 root 125. Now what I'm trying to say here in the sense that is what? The number we are going to multiply together in 3 places. What is that number? We are going to multiply together in 3 places that will give us 5. That number must be the same. It must be the same number that I must multiply together in 3 places to give me 125. Let me guess. Yes, I've gotten it. That is what is 5. That means 5 times 5 times 5 will give me what? 125. Now, getting the number, so the answer here is what? Is 5. So then I say 5 all bracket of 1. Then we have 5 raised to power 1. So which is mathematically what? 5. So this is how to use the law 6. Now I want to move further by talking of the law 7 of these indices. Law 7 of these indices. Now for the law 7 of these indices, law 7, we are talking of, is also similar to the law 6. We are using the same thing, but here the numerator of the power is no longer 1. Now we are talking of x raised by a over b. Now, which we are saying now, the denominator here is what? Is b. So we have b root x, all bracket of a. Now, I think, am I making sense here now? Now, let's bring out a problem and use this law to solve the problem we have in now. Now that I want to put on the board now. Now, one of the problem is, in mathematics, if you don't want to call it a question, you can call it a problem. Now, one of the problem I will bring out and we are going to solve, a mathematician only solve a problem. Yeah. So here we have, let me come back saying 4 raised by 3 over 2. Good. 4 raised by 3 over 2. Here we are going to use this law. Good. Because the numerator is no longer 1. Yes, the numerator is no longer 1 again. So solving further, we are not going to say, okay, yes, what is my denominator here is 2. And I told you that the denominator will always come as a root. So we have 2 here. So I'm going to write 2 root 4. Mind you don't need to put 2 here again because of the roots. So we have root 4 on. So what is our numerator of the power? What is our numerator of the power? Our numerator of the power is 3. So I am putting 3 here. So what is that 2 number I can multiply together to get root 4? Is 2. We've done it before. We have 2 raised to power what? 3. Which will give us what? 2 times 2 times 2. Which is what? 8. That means 4 raised to power 3 over 2 is what? Is 8. Let's try another question. Another question here is 25 raised to power 2 over 5. Yes, 25 raised by 2 over 5. Let's look at this question now and let's get something meaningful from it. We are going to use the law 7. Why am I using the law 7? Because it is similar to law 7. In this kind of question, you're not gonna use the law 1. You're not gonna use the law 2. You're not gonna use the law 3. Why? Because it is not even similar to any of those laws. When you are solving the law of indices, there's a certain kind of protocols that you have to put in consideration before you start solving. And what are those protocols? You have to compare and contrast the question or the problem you want to solve to the law. Now, when you understand the question, and they will tell you the kind of law you will use. Now, here I'm going to solve now because this is my base. And what is the power of the denominator is 5. So we have 5 root 25. Am I communicating now? So, pardon me please. So here we have to use 32. Let's use 32. Yes. 32. Okay, so in power of 2. Now, what is that number that I can multiply together in 5 good times? Can you see it? What is that number? I told you that the number must be the same. What's that same number that I must multiply in 5 good times to get 32? Now, let's start. Is what? Is 2. Let's check it out now. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times this 2 is what? 32. So we've gotten it now. Is what? Is 2. So here we say 2 raised to power what? 2. Can you see where the power now? The numerator is what? Guys, the work of the numerator now, which will give me what? 4. Are you with me now? So this is what we just need to consider about the law 7 of what? Of indices. Now I'm going to bring out a kind of more complex questions on law 7. Then we are going to solve it out together. So let me clean the board